So the students have already developed the robotic hand, and that is a prototype for now. The question is, what comes next? We will try to discuss that today. Well, so far you've learned about designing a robotic hand, how to build a robotic hand, how to model it, how to control it, and how to run simulations for the robotic hand. Some of you have already started doing more advanced methods in controlling and training the robotic hands using reinforcement learning. So for the next step, the students might want to think about how to develop their prototype into a commercial product. And that means you might want to make a startup in the future, and that's why we're here today. So let me welcome Professor Mirko Meboldt. And Professor Mirko Meboldt is an expert in terms of product development and product design. And today he will tell us what you need to do to bring your prototype towards a commercial product, or at least he will give you some idea about how to embark on that journey. So if you want to get a robot into a household or into a factory or into the fields or like into any place outside of your current lab space, that's a really different topic than what you so far had done in terms of designing and prototyping. That requires innovations in a much wider range of topics. That means you need to figure out who is your target customer, how to effectively manufacture your product in large quantities, and also how to make sure that your product actually runs reliably. All right, so before we go into the detailed aspects of how you can transform your prototype into a product, let's first talk about startups and big companies. Mirko, tell us about it.
Yeah, I think the major difference is, so the big companies, they are the champions in the market, yeah. So they have an established way, and their unique element is that they do what they do best, or the highest quality and the best price point, yeah. But they don't do it differently. Startups, they do things differently, and in a company, the worst thing is change winning rule, yeah. So, for example, if you see this in everywhere, you have this kind of innovation where you've in a short of term a dramatic shift, yeah, in market shares. This is where innovation happens, yeah, and you can take it with Nokia and iPhone, yeah, or you can do it in the car manufacturing with Tesla emerged, and in the beginning, so Tesla claimed they want to change the way we drive, yeah, with electric cars, yeah, and the first Tesla was a shitty product, yeah, they looked for a niche, yeah, where they have a customer who wanted to have this kind of special product, yeah, and the Roadster is a perfect product. Roadster, it's not a mobility car, it's a prestige car. You have a high acceleration, so you have a customer base who is really willing to do it. But if you introduce, for example, a Mercedes or Volkswagen, yeah, with a battery which you rely on mobility, yeah, you would not accept it, yeah. So, and this you look for your niche to have a loyal customer base and to grow with this, and over now the sixth or seventh generation, they are really they are a real car manufacturers, yeah, but they evolved, yeah.
They took 6 different models to bring out.
But I think this is iterative learning. So the first product of a new generation is always a shitty product, yeah, and it will all evolve, yeah. Also the first iPhone, yeah.
But if it's a really, let me use your words, shitty product, why does anyone buy it?
Because you're focusing on a very specific niche where you solve one specific problem, yeah, and you need to find this kind of niche where you said, I want this product, yeah, and you don't need, so it's not about scale, it's about penetration, yeah. So Volkswagen, they think everybody about scale. Tesla thinks about penetration, so you don't need 1 million customers. They only need 10,000 customers for the first year who are committed to buy the product and give feedback. And then you say, okay, this is not working, and then you really have a targeted, problem-oriented development of your product.
Okay, but how do you convince those 10,000 people?
I think it's I think with Tesla, I think it was really picking this kind of niche so normally, so I consider
like the electrification that you're saying.
Electrification.
Yeah.
So I think I remember when I first drove an electric car, I was thrilled by the acceleration and how it is. So it's exciting.
Yeah.
And also this kind of a roadster, is something which you normally, so it's not the question of those people buy it where they have the money, So because the roadster is not a mobility car, it's a car because you want to have it, and if you have the money, you buy it.
Makes sense. Okay.
Yeah, and it's always, I think there are a lot of very stories that it's finding the first niche, and I think also the iPhone, it was introduced on one carrier only in the US, in a very small market, and it was, all the features did not work in the first generation, but they created the excitement, they had a very strong enthusiastic customer base, then solved the problem, and then they grow. So it's the first thing, it's about penetration, and then it's about scale. And the problem is big companies think about scale at the beginning.
That makes sense, because I remember the first iPhone impressed me by the fact that I could swipe, because there was something I had never seen before. And like anything else didn't matter, I guess.
But in every option, you don't need swiping.
Yeah, it was just intuitive, right? So from that perspective, so can you also give us maybe a quick background on the difference between Roombas and all the other big companies in terms of vacuum cleaners?
I think this is a great example, because innovation goes always along with breaking existing rules. So, and if you think about vacuum cleaners, one of the key companies is Miele. And at this time, I had a conversation with the innovation team from Miele, and I asked them, so what about robotic cleaners? And they said, this is a product generation which is not on our level, because you get in touch with the dust, and this is something we don't know, because they were so proud that cleaning is clean, and the first generation with the robot was messy, so this was something which was a no-go area, so they did not touch it,
It wasn't perfect enough for them.
It was not perfect, because our customer would not accept it, because we don't want to that you get in hand contact with the dust. So they did not enter this field. An interesting thing was that in parallel, another company is Vorwerk. They identified that they took another decision that this is an interesting field, but they said we have no competence in robotics. So they looked for a joint venture. So they spotted Nito. Nito was a spin-off from, I don't know, a spin-off from the university in California, I assume Stanford, but I'm not sure. And they were really going to the field with the core components of autonomous mobility. They came also from soccer robots. And they said, you have the navigation, we have the competence with cleaning, with brushes, and they did a joint venture, and so they separated the market. So also you can buy Nito products and Vorwerk products, and this was a very fast and cheap successful development. And so over the time, so in 2016, then Vorwerk acquired 100% of Nito, and now Nito also as a brand, I think in 2023, this year, also vanished. The website is still there, but now they're closing the plant in the US.
So it's all Vorwerk now.
It's all Vorwerk.
Interesting. So now let me ask you this question. Once I've designed a prototype, and this is probably not a simple question. So once I've designed my prototype, how can I sell it?
I think the playful thing is in academia that we tackle the status quo. We are all about possibilities and functionality. So if you want to go a product, nobody cares about the functionality. It's about value. So what you have to test, your test case is not anymore the functionality. For example, with this example, it's about soft robotic gripping. Can I grip something? But if you want to enter the market, that do I add value in a business case? And are we cheaper, or do we solve a problem? So it's about solving a problem with an economic benefit. And this is a different story. So you need to define a test scenario to test your business case. Yeah, you need to switch it. Yeah, and I think defining this kind of value-driven test cases is the most challenging element. Yeah, because you can spend, I think, the next 100 years of developing soft robotics. Yeah, the question is, what is good enough that you can find a business opportunity
that people will pay for, right?
People will pay for, yeah.
Makes sense. So have you heard about this making a creeper from a spider?
No, I've seen it in your slides the first time, and I was really somehow fascinated, but it's also some kind of, so I'm not afraid of spiders, but even so, I find it to have a dead spider gripper is some kind, is a little bit weird.
So you think you could make a product out of this?
It's the same. So I think if you overcome the ethical concerns, yeah, to kill spider to have a robot, this is one thing. No, I think this is a nice example. The difference between invention and innovation. Yeah. So innovation is always the market answer. So if you have any disruption, yeah, so it's the successful penetration of a market where you have a market pull, where you have really a demand.
Yes. Yeah.
So I think it's
here the more invented, just a new research-worthy publication that came out of it, I guess.
But I think it's
maybe in 10 years, maybe we see actual robots just being spider-based. So when we produced our robotic hands in the context of this course, we had to use a lot of 3D printed parts. We used one of these very readily available FFF printers with filaments, and lots of them were used. So the question is, can we make a product with that?
If the quality is good enough, it works. Yeah. So the question is, what the problem is. Yeah. If can you scale it? Can you make it cheaper? So I think what is so great is to understand. So when I did when I started studying, the only startups were informatics because they had the production. Yeah, production is you send a code on a CPU. Yeah, then it's you can run it. Yeah.
Yeah.
And I was last year educated on a drawing board, so production was not achievable. Yeah, and now production is there. Yeah, and you can do FDM printing, and on a you can test the concept. The question is, do you have the durability? Do you need to, can you scale it? So if you want to scale it, it's injection molding is better. I think it's a great tool to learning, to understand the product. And then if you know that you have a market you want to scale, you normally have to do the transition to another technology, because 3D printing only makes sense if you have a unique advantage. Typically, the only advantage is it's fast and cheap, but not very reliable.
Okay.
Yeah.
So when we talk maybe about these fast and cheap but not reliable, can you tell us a bit more about these aspects, like the rigidity, toughness, minimizing the impact of variations on the product? So how can we achieve that, and why is that maybe important?
I think after my PhD, I joined Hilti, and I was part of a development team which was running. So it was 18 months until market launch, and the product was ready. And so I said, the product was ready, looked like a serious product. And I said, okay, what will we do the next 18 months? And they said, the tough part will start, because the first 98% of a product is simple. The last 2% to ensure that the product under the condition of a scaled production is really achieving this quality that with every user under every environment condition over the lifetime of 20,000 cycles, it has the same performance. This is a real challenge, because typically in the research lab you have skilled personnel, they assemble it, they can tweak it, it works, yeah. But then to say, now we want to have someone else produce it at a scale of 20,000, this is a different story. So it's a complete new development. Yeah. So typically, so from my perspective, if you have a product which works, you minimum develop it 3 times. Yeah. The first time is really, it's about understanding the functionality, then make it reliable, and then bring down the costs.
I once also heard from someone in a company I worked before. They told me the longer you work there, you get these once in a million instances occurring, like once in a million failure cases occurring. Like, how important are those for startups versus, let's say, big companies?
I think it's, so the question, the problem is not the failure, it's the risk which occurs from the failure. So for example, if you, so in certain business segments, you want to have 0 failures. For example, at Hilti, we had safety critical anchors. Yeah, so every elevator is fixed with an anchor, and you don't want that 1 in a million anchors where an elevator is fixed with falls down. Yeah, so they are So, but if you have a power tool, and 1 of 1,000 power tools fails, you don't care.
Right, because no one falls down.
Yeah, nobody falls down. You bring it. You have, so it's always the question: what is the risk? Yeah.
Okay, that makes sense. So maybe just in your words, what are the differences between this prototype design and the truly commercial product for this robotic hands? Like, what would that be?
So I think your head is fascinating, and you proved that it's feasible. So the goal was, is a soft robotic hand possible and can we control it? This was your challenge.
Yeah.
Now when you shift to a product, to say, okay, can we produce 1,000 robotic hand in the same quality, and what is the durability? So what are the cycles? Yeah. So 1,000 cycles, 10,000 cycles. Yeah. What is the cost? So I think also, if you the cost, I think you have quite highly motivated PhD students manufacturing the robotic hands. Yeah. So if you would pay a factory hand manufactured by PhD students, it would be not economically feasible. So I think bringing down the cost, reliability, this is a different challenge. Yeah. So I think what I always, I think we have this kind of concept. I think as a researcher, you have an idea, yeah, and you prototype your idea, and you have, I think you always are in the land of the wishful thinking, yeah, because it's so cool, you can do this. But as soon as you try to enter a real business case, yeah, where you really have to deliver something which really is reliable, yeah, you have to cross the line of truth. Yeah.
So down here, when you're saying idea, we are in the concept. What
so
is
I think to understand. So I think typically everything starts on the low fidelity. Yeah. You have a concept. So you want to develop soft robotics. Your idea is to have a hand. So it's very basic and on a conceptual level. Yeah. And also for your research, yeah, to prove that it's working, you need to let's take an on this card, because this explains the action. You have an idea, and what you do, so you have your idea and you need to build the idea as a prototype, so you deliver something which you can test. Yeah. So this takes much more effort that you said, okay, I need to understand the manufacturing process, I need to understand the material, I need to understand the assembly. So there are many layers you have to understand to come from the idea to the prototype.
Yes. Okay.
So now, if you said, I want to go on a product, so you want to specify your product that an external manufacturing, you need to have a much more sophisticated refinement and blueprint, yeah? And then the blueprint is produced from someone else. And I think this is the big challenge, how to navigate from an idea, yeah, from the concept to a delivery, and then iteratively refine it, yeah, to scale it up, yeah. Because I think, how long does it take to produce the first hand?
Well, if we count for all of the months of iterating on it until it worked, there was probably 6 months or something.
Yeah.
like this,
So so if you want to mass manufacturing, I think you need to produce it in 1 hour. Yeah.
Yes,
so,
exactly.
So
yeah.
and I think this is something where you need. So I think the next generation is not in 1 hour. So the next generation is in 1 month. Yeah. And then you refine it. I think this is the where you navigate. Yeah. So this constant refinement from your concept, which you typically on the academic side, and to deliver something, yeah. And in if you want to test something, you need to deliver something, yeah. If a company comes that I want to test in my production there, then you need to deliver it on a much more refined level, yeah. And I think this is the challenge to navigate in this environment, and there are certain hurdles. So we see that. So this is the crossing effort, yeah. So even on an academic stage, yeah, to produce the first delivery of a robotic hand is painful, yeah. And it's to prove the reality check. Can I build it? Yeah, is you're crossing the line of truth to test something, yeah. But if you now say I want to scale it up to a mass production, yeah.
That line gap gets larger.
The gap gets larger, yeah.
Okay.
And you need to learn how to jump over this gap, yeah. And I think this is something which you learn to handle this gap, yeah. And this gap has many dimensions.
So does it mean we should like jump that gap very early on and back again and forward again?
Yes.
So it has to be continuously done.
Yes.
So that maybe that also lowers that gap as you go up.
So you learn how to handle the gap.
Okay.
Yeah?
Makes sense. So then maybe let me ask you another question. So what are some of the more successful startups that were born here in ETH, Zurich, or in Switzerland in the broader scheme that you know more about or you would like to share?
So I think with one of the success stories, Keeper Systems from Prof. Andrea, and so when I met him the first time, so I was really curious how he made this transition, yeah. And I think what was really fascinating is that the key is about reliability and robustness, yeah. And this you only learn if you deliver, yeah. And then I said, how do you do it? He said he won several soccer robotic championships, yeah. So he was able to deliver, and then they understand the robotic side, yeah. And then they had the idea of this lifting element, and they said it was so hard again, really to start from scratch to scale it up, yeah. But it's all about reliability and robustness. And I think in this test case, yeah, if you build your robot, your code to have a soccer championship where everything needs to work on spot is something which works. And the same thing is, then I said, okay, what is next? Yeah, and he said, the next thing is flying drones. Yeah, and the things he did with Cirque du Soleil, yeah, was something. This is the best check to work on the reliability of robustness, and it's same. So for a commercial application, this is a shitty product, yeah. So you need to find a niche where you add value, and this kind of environment of entertainment to fascinate is a very controlled small niche environment where you have an exciting customer base to learn.
Yeah.
Yeah. And there you need to cross this gap, yeah. Because if you can do this in our Maschinenhalle, yeah, to do juggling robots, yeah, or build a bridge, yeah, this is fascinating, but it's a very controlled environment. To do it live on stage, yeah, is much more challenging. Then to do it in a real factory is much more challenging. I think this kind of really real world product-oriented test cases, yeah, is something which I think does love in a fascinating way. Yeah? So I think you see this line of hiring the bar.
So that means they basically had the initial gap that you showed earlier, going from making a drone that can at least fly for a Cirque du Soleil show. So it lasted maybe for an hour, and it could do that even when it had to do it right on that day. So it didn't just work the one time in the lab, but they could make it work multiple times.
Multiple times, and also with I think you have a lot of disturbance. So in the lab environment, you try to eliminate all disturbance. Yeah, you have people interacting, perhaps someone is destroying something. I think you have a lot of challenges where you learned in a controlled environment. Yeah.
So as you were telling me the story, I was thinking of the summer when Thomas, who was one of the PhD students in my group, and Benedek, another research scientist, and we traveled to India, and we took the first version of the robotic hand prototype with us, because we thought it would be a good idea to try it on a TEDx stage there. So and when you arrived there, we couldn't bring everything with us, right? Because getting this to customs, flying a whole table and everything. So we had to rely on them giving us a table, but the table wasn't there when we arrived. So imagine building the table before. And then it all worked out, and the biggest worry was the robot hands. But Thomas was showing a robotic leg, and it was always working for every single rehearsal. And then the moment we went on stage and we were doing the final quick check, it was not working for the very first time. And that was the most shocking part, because the robot hand was ready to go and was all working, which was the one was constantly before like failing or some minor failure, and the leg wasn't.
Did you figure out what was the problem was?
Yeah, so then fortunately the moderator on stage they were so prepared for the eventuality of this to happen that we were able to say, I was saying that 2 minutes before the curtains went up again, they pulled us off the stage, and we were right outside. I could still look onto the stage. And then Thomas, in a very routine, very sort of like Germanic way, he was like taking the muscles of the robot apart one by one, inspecting, and he found that one of them had broken by just touching it, and he figured out something must have happened during them handling it all around and bring it on the stage. And we fix it right there, we attach new tendons to it, and then it worked. So
what a gifted person to multitasking. So
I was so grateful that he kept a cool mind at that moment, but it totally reminded me of it was not a product at all.
Yeah, but even this, I think this is, when I use the term shitty product, I said it's not reliable. So but even for this single use case, it was not reliable. Yeah? And now I think this learning, to make it robust, I think this is shifting from the functionality, and I think from an academic point of view, you always look on the quality functionality. Oh, it works. We observed it. Now, great. Can you repeat it 1,000 times? Yeah. Right. Can you repeat it if you build 100 hands that 100 hands do the same job? Yeah. And I think it shifts. Yeah. But I think this makes the field of development so exciting, but quite painful.
It totally makes sense.
Yeah.
So. You just mentioned to us Kiva systems, and one might say they were just on the ground, like driving around. What can you say maybe about other startups that have started doing more like animal-like motions?
I think the spin-off for Marco Hutter is also it's fascinating, because what is also so great, I think there's also a well-known US company which has the same. But I think if you look on Switzerland, what is the DNA of Switzerland? It's really solid engineering, yeah. And I think the animal, it's explosive ensured, so it's XEX secured, so you can also work in a chemical plant, yeah. And you can walk through water, yeah. So from Boston Dynamics, yeah, it's an open system, yeah. You are not allowed to go in an explosive area, and when you go in the water, it will die, yeah. So I think it's a great engineering. So you see, I think the masterpiece of this is also the engineering behind, yeah, which is what reliable and challenging. And I think what I also like it is, I think the game changer for Marco with the animal was winning the DARPA challenge, yeah, the subterranean challenge. This was a well-defined test case to demonstrate what you are capable about. And this is a test case to demonstrate, which then people also, the market see, oh, he is able to do the test case. So this kind of challenges, yeah, are very important, because I think to have a good test case, and I think this is a great example, yeah. And
of the test case for the robot to
yeah.
show they can actually survive a
Yeah.
subterranean,
Yeah.
wet, messy environments,
Yeah.
right? Maybe can you tell me about another startup that doesn't come to my mind, but we should highlight here?
So I think Skevo is the same thing. It was an idea of graduate students who want to do an really stair climbing wheelchair, yeah. And then when they started in the parallel, Robert initiated Cybathlon, yeah. The Cybathlon is also a test case, yeah, a realistic test case where you have a controlled environment to learn what you're capable. So the tragic thing of Skevo was, yeah, was that they participated in the Cybathlon and they were the champions, yeah, and they focus on the technology. I advised them at this time to do the usability testing, yeah. So it's not about the technology; it's about human interacting with the technology, yeah. And they had when at the start, nobody has not anymore to touch it because the pilot need to navigate himself, and the pilot was quite nervous, yeah. And they had a touch screen, yeah, and in the touch screen they had this kind of, he somehow touched the screen for the emergency shutdown, and the confirmation field was on the same state, and he made a double click and he made at the start of the Cybathlon emergency shutdown by not intended, yeah.
Oh.
And then
they failed the competition.
They failed the competition. Was really dramatic and really painful, yeah. Oh. But I think this learning, yeah, was also really a key learning, that they really took this topic then very serious, and they developed a great product. They won the Swiss MedTech Award, and now they are really a growing company, and they have a sales, and they have it's great to see. Yeah.
Yeah. This also reminds me of the MIT team that joins the previous DARPA Robotics Challenge that was in 2015. You might remember the funny videos of all of these humanoids falling over, tipping over, trying to open the door and breaking.
I haven't seen it.
You haven't seen that? So it is an amusing sets of failure cases, because at that point, in 2015, the robotics development for humanoids was, I would say, still in the early stages, and people were usually only showing their lab videos. But there, they had to bring it out to a military facility and show it to work for a whole day and opening doors, but it was very slow. And so the whole press was there, was able to film. So all of the failure cases were all perfectly filmed as well, and they were probably the most famous afterwards to be sent. But the story behind the scenes that I learned from the MIT robot was, they were driving with the robot a car. So they had the robot go into the car, sit down in the car, and then use its humanoid foot to drive the gas pedal and steer it. Very slow, but they were able to manage to go. And then they arrived, and then the robot was getting up, and it was all human controlled. So none of it was autonomy, right?
Okay.
So all of us are describing to you.
Remote control.
Yeah, so they had sort of higher level motion primitives, you might say. And then what happened was that they had a controller here for doing this, and then the human error came into place. Because what happened next was that they forgot to turn off one controller before they turned on the next controller. So they had still the so-called foot pedal customized controller to just do this foot pedal motion while they were trying to have the humanoid exit from the car. And as it was exiting, it was doing this while trying to do foot stepping. And because there was no, like, I guess I would assume in a product, you would probably make sure that these two controls cannot coexist at the same time. That wasn't put in place.
But
so,
I think
it fell over and everything broke.
But I think this is about learning. I think this is, so typically in a lab environment, you do the testing because you prove that everything you thought through is working.
Yes, yeah.
In product development, it's about, you need to test to understand where the limits of your product are and to fix the limits.
Yeah.
And this is the paradigm shift. Yeah. So typically, in testing, if you are on the product side, you want to replay how can I destroy my product, and how can I bring my product to the limit. And this is for something, if you love so if I start destroying your soft robotics hand, it's painful because it's your baby. Yeah.
Yes.
So but I think this is important. Yeah.
This is the only true use case, right?
Yeah.
To actually show that you can make it and break it. I think here you can see actually the example of the robots, and you see how painstakingly slow at that time it was still moving, and all of the extra equipments it was carrying around with itself. That was the one from another university at that point. But you have imagined this one.
I've seen this video. Yeah, I know. I've seen. Yeah.
And
you
so
need to be patient.
So, but what was actually, you were talking about PhD students, so they were then obviously kind of really bummed out, but they still wanted to win the competition. So most of the people on the team not being hardware engineers but software engineers, because they got the robot from Boston Dynamics. Boston Dynamics was producing the robot, they were doing all of the controls and software. They basically figured out to transfer within one night, because the competition continued the next day, all of their code so they could do everything single-handedly. Because after the robot had fallen over, one hand had physically broken. And they had everything else pre-programmed for this competition to do with two hands, and like opening door and everything else that came. So they managed to still make third place in the competition with a single hand afterwards. That's just a part of the anecdote.
And I think and another one is Wingtra. Yeah, there was also it was a focus project at this time. Packflyer, the two lead students.
It was called Packfire.
Packflyer.
Packflyer.
So the story was with Basil Weibel. So he was. He had an economics degree from Uni St. Gallen, and then he said he wanted to do an engineering degree on top, and he had the idea for the Packflyer. And so he had this vision, and his idea at this time was to have a medication delivery for Africa, so Packflyer to have packages delivered somewhere. And it was a quite playful approach from a student project. And then when I think they were the first one who really thought about this combination of hovering and long distance flying. So this was the first teams. They had a quite complicated setup. So in the first time they had this shifting propellers, and they struggled with everything, but somehow they demonstrated it. And then the first use case. So then at this time, when they thought about building a startup, it was the topic of precision farming from John Deere came up, and there was a group from John Deere here, and they said this is interesting for precision farming, because in a drone you have large scale, so the distance from drones are too slow, but if you have a flyer, you cannot have a precision pictures, And then it started, and then with this traction, with this kind of demonstrator and a market pull and this test case, it really evolves, and it's really fascinating. And so and also the core team, Armin Anbil, he is a CTO. He also did his master's thesis in my lab, and it's really great to see how they really navigated to really iteratively and learning and evolving. My key recommendation is to be very clear about the test case. So what is the test case you want to deliver? And to think about the test case in this way, that you think, okay, who you're selling the test case to build something, a test case which should be in German with the Anschlussfähig, so which can be easily
connected to
to someone who said, I have a problem, that because it's always this what you are doing is technology push, but for real innovation you need the pull from the market, so you need to somehow present the ideas at such a maturity that people say, hey, it could be helpful for my application, and you need to start the conversation with the customer. And you can only start the conversation with the customer if you have an MVP, a minimal viable product. And as long as you know customer, you need to somehow create this idea of a potential application to demonstrate this MVP, that someone's coming, okay, I need exactly this, yeah.
Mm-hmm. So that is the sort of the product or the future product to market fit gap that we have to figure out. So I hope with that sets of both insights into startups versus big companies, into what does it really take to take a prototype towards a product, and what does it really mean. Like, technology is not everything anymore. Technology is assumed to be a given, right? Technology needs to be working. It needs to be more the niche that we need to find. I hope that helped for getting you excited, to get you started on the topic of thinking beyond what you learned in this course and go towards maybe founding your own robotics manipulation startup, or another topic that you got inspired throughout this class. So hoping to see many robotic startups to emerge in the future after you have learned how to do robots, how to build robots. And thank you again.
Yeah, it was
Professor
a pleasure,
Meboldt.
and I'm looking forward to see the results from your project.
Yes, and we are looking forward to also welcome you in the classroom.
Yeah, and our focus project still needs a hand. So
yes.
we're a gripper.
Yes, I'm sure we will have a couple of those for you then. All right, cool. Thank you very much.
Thank you.
Yeah.